What up, YouTube? This is Banjo Fan 3 here with another physics video. My first one was just a brief overview. My second one, I will admit, was pretty crappy because it's so much easier to display on a board, which I didn't have a board, so I drew on a piece of paper. It could have been so much better on a board. I wish I had a board. I kind of want a board. If you can find a board for me online, that would be amazing. I would buy a board. Anyway, so this is the second unit, but third topic I'm going to talk about. It's vectors and Newton's laws. And if you can't see, that's Herbert. That's Herbert right there in the corner. Bang. This is when I first got a Herbert. Don't ask about Herbert. Herbert went suicide. No, I did not murder him. He went suicide. And don't worry about Herbert. He's a rock. Alright? He's just a rock. Anyway, first piece of advice, which I will just scream at every video I will make. Look at the equation sheet. Alright, this equation sheet, actually this equation sheet might not have vectors because vector is just an easy concept. But Newton's laws as well. Actually, those are more concepts. Still, but this whole unit of vectors and Newton's laws all depend on they're all like visual things. If you can visualize them, you'll be fine. And once you get this concept down, the rest of the year will make a lot more sense. Except for circuits. Circuits never made sense. Circuits was the one I had trouble with. But anyway, I'm not gonna whatever. Anyway, so if you're lucky, I will edit this video and put a part with Vector from Despicable Me, I think. Yeah.
Vector! That's me, because I'm committing crimes with both direction and magnitude. Oh yeah!
So if I remember, I'm probably gonna butcher this quote, but here's the best I can do it. Vector is a magnitude with a direction, or something like that. I don't even know. But really, for those people who can't understand what a vector is, get on my handy paper again. It's as simple as I got all over my hand. Blah. It's as simple as a line. It doesn't even matter what kind of line. It has to be a line. A line with a direction. So a line plus a direction is equal to a vector. Alright, so this is probably going to be one of the most easy things to explain, but the hardest one to actually understand if you're not a visual person. You have to be visual to do this. I will admit it's very hard to just think of it. Alright, so also you have to know your trig functions. Sine and cosine. Alright, I don't know if you can read it because the screen is blurry and stuff, but those are the two main trig functions you will be using this whole unit. The only other one you will be using is tangent. Alright, and what do these find? What could these look for at all? What does this even do? Alright, so let's say you have a vector, alright? Random vector. And you want to know what impact it does, or how much displacement or distance you went in the y direction, how much you went upward. You don't care how much it went that way, fuck that way. just pretend like there's a wall there. Like, I can't go. There's a freaking wall. Oh, but I can go up. I'm just gonna go. That the sign will help you there. Let's draw a picture of a triangle. Alright? So, if you know your trig functions at all, you'll know that sine is in the y direction, right there. Cosine is in the x direction. And tangent is the degree. With, and all this together, all this stuff, is equal to the huge, big-ass vector right there. Bam. Alright, so pretty much to find out a vector, right? Oh, my screen's lagging. It looks weird looking at myself. Anyway, to find out one thing on this, you need to know two other things. And this goes back to the kinematics equation. V is equal to V naught. Oh, so yeah, V of x or y. V of x or y is equal to V naught times the trig function times theta. I don't know if you can see that. V x or y is equal to V naught times the trig cosine theta. Bleh, can't even speak. Anyway, so how do you figure out the y direction if all you know is y? Alright? No, if all you know is everything else. Let's say you know everything else. How does this help you? Well, there's also one more equation that you should know of, but they didn't tell you in the equation sheet. Pythagorean theorem. A squared plus b squared square rooted is c. Alright? So there's if they give you everything but that and they tell you to find this, you have two ways to find it. And I mean, I guess you can use other trig, but they don't expect you to know that far of trig. I don't want to teach you that because I'm too lazy. If it's that, you just plug it in. What do you know? You know the final thing, right? The final change of... No, you don't know the final change. Wait. Yeah, you don't know the final change. Alright, so this blah 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 is a mystery. But you do know the original. That's the V. Let's give it a random number. It'll be like 5. It's going to be a freaking 5. Alright. And then you also know theta, the angle we should launch that. Alright, so you're going to be like 10 degrees. Let's say 10 degrees. I don't even know. I'm not going to actually solve this because this is such a weird trig. And now you got to figure out what trig you're using. Well, since it's the y direction, alright, you use sine. And that is equal to your y component. And same concept for the x direction to figure out your x. Now, to figure out your angle, though, that's a different story. You have a few trig options, but I would recommend tangent because that's the easiest to figure out. Pretty much for tangent, this is kind of awkward to hold. Oh shit! First of all, let me let you understand this. You can also do these backwards to figure out the angle. I'm just gonna say that straight there. But if they give you that and that, don't try to do Pythagorean theorem and then backwards reverse. No, that's too much work. Just do tangent, alright? So tangent of whatever angle they give you is equal to opposite, which in this case would be y, over x. Alright? So it's going to be this mofo over this mofo. Just think of it like sex, alright? Sine is a girl, cosine is the guy. Alright? Girls are always on top. If not, what kind of relationship are you in? This is that would be cotangent. Alright? That's just... I don't want to get into details what that would be like. That'd be like trans. I'm not against trans. I'm just saying, you know. This helps you remember. Girl over guy. Sine is a girl. Cosine is the guy. Just think of it like Sarah and Cyrus. which is awkward because if you know who I'm talking about when I say Sarah, it's awkward. Anyway, this was nasty. To figure that out, pretty much, you have to know this thing on your calculator called inverse trig. So theta would be the inverse tangent to -1, in parentheses, x over y over x. It's pretty much just your basic algebra, and with that you can figure out the angle. If they don't give you that and they only give you like that and that or that and that, please don't go through the hassle of Pythagorean theorem. Alright, that's just way too much. You're thinking way too much into this. I mean, unless you don't understand the inverse tangent at all, or you don't understand the equation, don't convert it to the other things. Think smarter, not harder. That's something my teacher would always tell me. Now, let's see what else is in here. Oh, by the way, if you don't know your trigs, like what angling they are, like cosine is 1, and then sine is 0, I like the 0 degrees or whatever. Like, you don't have to memorize that, but it's really helpful if you know your pre-cal. Anyway, so far I'm looking through this, and that's pretty much what I'm finding. Resultant. Alright, resultant vectors. When you add more vectors together. I actually made a calculator program to do this for me because I understood the concept well enough to just plug in my calculator. Done. Ta-da. How do you add vectors together? It's very easy for me, but I'm not asking if you know. Rhetorical question. Do you know? Do you? Mr. Philly. I don't even know if you happen to know what I'm talking about. Anyway, so let's say you have a random line. Bam! You have a freaking random line. I'll even make it bolder for you so you can even see it more. Bam! Alright? Now, it goes from the center of God knows where, which you can put as 0, 0, the origin. Alright? Now, right now I'm not going to go into details about the numbers, but just remember the middle. Everyone should know the middle 0, 0. If you don't know the middle 0, 0, please go back to algebra. Most of this is just algebra. I mean, people think it's way too hard in physics. That's what I don't like. Anyway, so you got that right? And now they give you a new vector. Alright? What do you do with that? Well, you can just imagine that at this point right here, I don't know if you can see that I drew like little dash lines. Little dash lines right there. Pretend that's the new 0, 0. It obviously won't be 0, 0, but you can just imagine. Heck, imagination. Who knew? Let's say it just goes that direction. Bam, right? And I'll highlight it for you because it's really hard seeing. Alright. Now, if they give you another one, you just do the same thing. Just draw as if it's another origin. But how do you find the resultant? That's the thing. How do you do it? If this isn't going to be 9 degrees every time, it's going to change. How do you know that, though? You tell me. How would you do it? Probably not answering me, are you? Nope. Not at all. Well, what you have to do is find your x component. Bam. So, like, find your x components. And find your y components. Bam and bam. And separate them. How do you do that? Trig. Because they will always give you this angle right here. They will always give you the angle. And they will always give you the direction. So, they will always give you magnitude plus direction. Once again, I had to do that. I probably butchered it. I'm sorry. This, no, it wasn't Pixar, was it? No. It was the thing that made Shrek. I don't remember what it's called. But anyway, sorry for butchering that line. Pretty much you get all your x components, and you get all your y components, You separate them, bam. Like all the X here, all boys here, all the girls here, alright? You separate the boys from the girls. That's why they have different bathrooms. Okay, you put them into their bathrooms, and now you add them together, alright? Sorry, my computer just, I went to screensaver. I had to fix that. Anyway, where was I going with this? So yeah, you add them together, right? So now you're combining I can't say bathroom because now it just sounds nasty, but I'll help you remember. You put them together, and in the end, it'll give you another freaking triangle. Alright? With all the X's and all the Y's. Alright? And what can you do with this? Inverse tan. Tan -1, right? To find out this angle right there. Bam. So now you have a resultant X and resultant Y and the angle. Now how can you find this the ending vector right there? Pythagorean theorem. It's as simple as that. Just manipulate your equations. Draw pictures. Pictures can probably be your best friend in this unit. Hopefully you understood that. Let's see what else is in here. And that looks... Oh, wait. Oh, that's it for vectors, but there's also Newton's forces. I'm going to need a new sheet of paper for this. One moment, please. Alright, so we got Newton's forces. I close my thing because I'm stupid. What forces do they teach you back in first? The four basic ones. Alright. So, what forces are acting on me right now? You know, forget even drawing it right now. What's happening to me right now? How am I sitting in this chair? What's going on? Well, let's draw a picture of me. Oh, yeah, I said I wasn't going to draw a picture, but now I draw a picture. Alright, here's me. Let's say I'm standing up and I'm not on the ground. I'm on the chair. I'm not on the ground, right? What's happening to me? Am I just like floating there? No. Two things are happening right now. One, I'm being pulled down to the earth by gravity. If you learn anything that I'm about to teach you about forces, is that if you are on a planet, you are being attracted by gravity. Alright? Gravity is happening to you, and you are going down into gravity. Or into the earth, because of gravity. Alright? Now, right now, that can't be the only force happening to me right now. Why is that? Because if that was happening, I'd be going through the freaking ground, and I'd be like, oh, what the hell? Ah, I'm in the ground. Ah, here's a bunch of dirt. I'd be in the ground, and I'd be like drowning. And eventually make a black hole. ... Happy ending. Anyway, so why am I okay? Why am I not going down? Because there's another force pushing me up. If this is the force of gravity, this is called normal force. Why is it called normal force? I have no idea. Why does it work? Because usually solid objects don't want to go through another solid object. Alright? And maybe if you're a ghost, you can go through transcendental force or whatever it's called. I don't know. I'm making up words now. And the person I'm making this video for is right now talking to me on Skype. So, anyway, normal force. It's pushing you up because it does not want you to go through the earth. Alright? What else is happening to me right now? A bunch of other forces. But right now you don't care about it because you're in physics 1. Alright? So for right now you're done with that. Hopefully you understood normal force and gravity force. When does normal force happen? When an object is on a usually flat surface and it's always going to be the opposite direction that it's facing. For example, you see this line right here, the line of the edge of the screen? If I want to put my hand here, right, there would be a normal force pushing away from it because my hand does not want to go through the wall, like bang. This is if there's no normal force. If there's no normal force, right now I'd be like, ah! Because gravity would be pushing me down. But if there was no gravity force, normal force would barely push me up, and then the second I get off the floor, I'd be floating in space. Yeah, pretty much. So there's that. They say neglect air resistance. You will learn about that in Physics C. Well, you'll briefly go over in Physics C, at least for now. I haven't actually learned anything too much about it. I just know that it's there. And let's go to other things now. Friction. What is friction? Why does friction happen? Because, let's say I'm on a slope. Bam. Alright? Gravity's pushing me that way. Normal force is pushing me that way. This is normal. This is gravity. And so far, it looks like I'm supposed to go that way. Why does it so that when you stand on a hill, you don't move at all? Why is that? Same reason why if you were to rub your hands together, your hands just don't go flying off. You make heat from it. How do you make heat? From friction. Because if I'm going to put my hand like this, it'll roll because it's a ball thing. But if you put it like this, why is it not falling down? Because friction is too much and it's pushing it up that way. So, in this picture, friction is pushing me up that way. Friction. Force of friction, force of normal, force of gravity. Now, how do you know which direction the friction is? There's two ways to actually remember this. There's a flat surface, right? And you want to go down the surface, like down the slide. Just think of it the opposite way. The slide, you want to go down the slide, but the slide's like, no, go back up, push. But you know, you're too fat, so you fall down and go down the slide. Another way to remember it is that there's normal force and friction force. If there is a friction force, there will be a normal force. And if you turn your paper sideways, you will see that this makes a 90-degree angle every time. Don't doubt me on this. It'll make a 90-degree angle every time. And so that pretty much explains friction. The reason why you don't want to go falling down a cliff, because you don't go falling down a cliff at first, is because friction is pushing you back up. There's two kinds of friction. I think it's kinetic and static. But I'm not going to get into detail about that. You'll learn that either later or in Physics C, or you'll never learn it ever in your life. Now, there's another force I'm not talking about. Let's say, by the way, I'm not going suicide. Please do not judge me on this next one. I am being hung from a rope because no one likes me at all in my life. Bang. Alright? Now, gravity is pulling me down. Force of gravity. But I'm not touching a surface or anything, so there's no normal force. And there's no friction force because there's always friction when there's normal force. And if there's no normal force, then there's no friction. So how the heck am I being hung from the thing without moving? How do people get hung without moving? Tension. Anytime you hear the word string or rope or pulley or some kind of word, alright, think the force of tension. Alright? How to remember that it's called tension? I just thought of a tug of war. Tug of war involves a lot of tension. Pull, tug, tension. Also, if you have enough tension, you'll break the rope. Fun saying. Anyway, how do you calculate any of these? Easy equation. This equation will help you throughout life, and if you're in Physics C, I don't care whether you know how to solve the thing or not, you will write down F equals ma. F is equal to ma. This equation saved my life on the free response. It's actually the sum of all forces, but just remember F equals ma, you'll be close enough, because you'll understand, as long as you understand the concept. So what does that mean? The sum of all forces is equal to ma. M being mass, A is equal to acceleration. Alright? Why does this matter to you? It doesn't at first. If they are equal forces, alright? So let's say this guy isn't moving, right? So the sum of all forces is equal to 0. What does that mean? It means he's not accelerating up, he's not accelerating down, not accelerating in any freaking direction. All 360 are, well, if this is a 2D sketch, it's 360. If it's not, then that's a really big angle. 360 square, I guess would be called. Or cube. No, square. 3D square, right? Yeah, wait. You get the point. Anyway, so sum of all forces is equal to 0, which means gravity is equal to tension. Now, how do you figure out gravity? Gravity is equal to ma, because the sum of all forces is equal to ma, so the sum of gravity is equal to ma. Force of gravity is equal to mass times acceleration. What's your mass? Let's say you're a skinny little boy like me, and you're 55 kilograms. All right, is your mass, and you're accelerating because usually it's 9.8, but for rounding purposes, I'm just gonna say 10. 10 meters per second squared is equal to acceleration. You just plug it in, and your force of gravity is equal to 550 newtons. And since force of gravity is equal to force of tension because you're not moving at all, force of tension is also equal to 550 newtons. Newton is the unit for all forces. Hopefully that makes sense to you. There are other equations that go with this, but I don't know if you'll learn them yet. Pretty much it's just, also, you will have, to help you, please, for your own sake, draw what's called an FBD, alright, free body diagram. It's pretty much these lines and stuff, but only the person, alright? Oh, without the person. Just draw the lines, alright? That'll show you which way the force is going, and whichever way the vectors and the sum of formation, either the actually I now understand why they put them together. The final vector, right, of which you put them together is equal to where you are accelerating, which way you're going. Alright? So if I have force of gravity here and normal force there, they're equal to each other, so they cancel out, so my acceleration is 0. Now let's say force of gravity is this way, normal force is that way, there is no friction, and some douchebag is pushing me across my room. Now, if he's continuously pushing me, and we are increasing in speed, then my acceleration is going to be that way, with the way he's pushing me, and the acceleration will determine which way the force is being applied. So force is being that way, there are no forces going that way because I said there's no friction, so bang, accelerate that way. Hopefully that makes sense. I don't believe there's anything else in this packet that will help. Oh, actually there's one more thing I can teach you. Okay, so I said free body diagram, right? Now, what happens when you have a pulley? What happens to the force? You have a pulley, right? And there's 2 strings. What does a pulley mean? Here's what it means. It's a trick. It's a trap. You have to pretend I'm Admiral Akbar with a huge giant squid head, as stated in Big Bang Theory. It's a trap. Anyway, so pulleys just mean you are changing the direction. For example, That's if they say neglect the friction on the pulley. That's just too complicated. Alright, so we got a pulley, right? Let's say it's this mofo. Alright, here's a pulley. And I don't know how, but I just found some string. Alright. We have something hanging on here, and we have something hanging on here, alright? And the force of gravity is being pushed on both of them, right? Well, just take out the pulley. What does it leave you? It's turning it. You're just turning this. There's a force of gravity of this going up and a force of gravity of that going down. And at some point, there's a tension going that way and that way, upward and downward at the same time at a single point in which they are equal to each other. So you can cancel that out. Doesn't seem too complicated now, does it? You just change the direction. And I believe that should conclude it because it's been over 30 minutes of recording. So this is Banjo Event 3 here saying I hope you understand Newton's... Oh, actually, I didn't even explain Newton's laws. Do you really need to... Okay, I'll explain Newton's laws. Okay. Sorry about that. The first law says pretty much inertia, which if you don't understand that, then you'll be harassed by it next year in Physics C. If you have Physics C, everyone's going to harass you. I feel bad because I didn't know what inertia was the first day. But I knew the concept, I just didn't know what it was called inertia. Anyway, if there are no forces applying on an object, alright, then it will not move, right? And if a ball is moving and no one's accelerating a certain way, it'll stay at a constant velocity. So what is this saying? Something that is in motion tends to stay in motion unless acted upon by an unbalanced force. So this right here, alright, let's pretend it's floating in space. Nothing's going to happen to it until a force comes out which is unbalanced or in a certain direction, or like it's more in one direction than it is another direction, and it will start to move. That's pretty much what it's saying. And if it's moving at a constant, it'll keep moving constantly unless something puts a force on it and it'll start moving in another direction. Like, that's the first one. The second one is a little more complicated. As described by my teacher, it's not the second one. The first one is saying I'm not the second one. That's what Mr. Kenny says. I'm going to have a hard time actually explaining this one, so I'm just going to leave you to deal with it, because I'm sorry I can't explain that. It's just pretty much saying I'm not the first one. And then the third one is saying for every action is equal and opposite ratio. What does that mean? If I punch you in the face because you're being a douchebag, you're pretty much hitting me with the same amount of force. Bang, right? My arm is hitting your face, and you're, but then your face is also hurting my hand. That's why when you punch someone with like a really strong body or whatever, the weak guy feels hurt because he felt more of the force. Well, the thing is, he felt it. They both had the same amount of force because equal and opposite. But the weaker guy, always feels it. Ow, my hand! Ow, my face! Yeah, same amount of force. And, sorry, again, I can't explain to you the second one. Anyway, it's been like 33 minutes or so, 34. I'm just going to stop here. It's Banjo Event 3 here, saying hopefully you understood Newton's forces. Bye. Oh, by the way, there's a lot more confusing ones.